Hi there, welcome to the sixth video in Integrated Math 3 Unit 2 video series. In this video, we're going to talk about how to get the remainder really quickly. There's a special way that we can do that. But before we do that, let's hop into more division. So I want to give you a little more practice with division when I warm up for today. So try these two problems using division, and then we'll go over them here in just a second. Okay, so in this this set of problems here, let's go to the next screen here and I'll show you number one. A couple of different ways we can do number one. You can do long division, so you can look at kind of the process there. Again, don't forget to subtract each time as you go. And when you do subtract, be very careful with the negatives here, because sometimes you're going to have two negatives, which when multiplied give you a positive. As a result, we're left with x minus 2 plus the remainder over the divisor. So x minus 2 plus 7 over x, this should be x plus 9. Let me change it real quick. X plus 9. Over here, if you do division by inspection, you can think about, if it's x squared plus 7x, 9 and what give you 7? 9 and negative 2 give you 7. So therefore, we need 9 times negative 2 out here, which would be negative 18. So that when we factor the x plus 9, we'll have something to reduce with. However, we can't change the problem, so we have to have plus 7 out there, so that's still negative 11 out there, but we can separate it out into two pieces. This quadratic that will factor, and negative 7, or plus 7. So now we have the two pieces. So when we take this piece here, this quadratic, divided by x plus 9, we're just left with the x minus 2, because these two reduce to 1. And then when we divide this piece, the plus 7 divided by x plus 9, that's all we get, is that fraction there. And as a result, you can see we are left with the same thing left over in both. So either way you do it, those are the answers there. For the second one, I'm not going to go through this step by step necessarily, but you can kind of see the work and follow that as you go. As a result, we're left with this quadratic, x squared plus 3x plus 4, with a remainder of 3. So we have x squared minus 3x plus 4 plus 3 over the divisor, which is x squared plus x plus 1. So hopefully you're able to get both of those. Again, if you didn't, go back and check your work there, especially check the signs as you go. Okay, so for today, our goal is to be able to use and understand what's called the remainder theorem. And so we're gonna hopefully discover that first, and then we'll look at see how we can actually apply it. So let f of x equal this quadratic function up here. So let's divide this function f of x, so this quadratic divided by x minus 3. So let's go ahead and do that together real quick. Whatever method you want. X squared, I'm going to use, let's do division by inspection on this one. So x squared plus 7x, let's see, minus 3 and plus 10 give us 7. Minus 3 and plus 10 multiply to give us negative 30. But we really need it to be positive 3, so we're going to add 33 on the outside. So that's going to leave us with x plus 7 times x minus 10, sorry, x minus 3, and positive 10. Sorry, trying to rush through things here. All right, so now when we simplify the plus 3's, or minus 3's there, we're left with x plus 10. And then when we divide 33 by x minus 3, we're left with 33 over x minus 3. So that's it there. So we have x plus 10 with a remainder of 33 over x minus 3. So that's number one. And we're going to look at maybe like what happens here, and then what do we get when we do this over here. So number 2 says find f of 3. F of 3. So that means we're going to substitute 3 in for each of the x's in the function f of x. So when we do that, we're going to get 3 squared plus 7 times 3 plus 3. So it's going to be 9 plus 21 plus 3 equals, let's see, 9 and 21 is 30 plus 3 equals 33. So do you notice anything in particular that happened here when we divided f of x by x minus 3 versus substituting 3 into that function? Do you notice anything? Hopefully, you see that 33 was the result of putting in 3 into the function, and then, oh, we see 33 over here. So let's see if that continues. Again, take a mental picture of what we have here. We're dividing by x minus 3, but we put 3 into the function. So keep note of that. But the result was the same. 33 over there, and then we had a remainder of 33 over here. Okay, so up next, let's try another one. We have f of x now as a cubic. We're dividing by x plus 2. Let's go ahead and do some long division here. X plus 2 into x cubed plus 0x squared plus 0x minus 1. Don't forget your placeholders. Let's see. X goes into x cubed. X squared times. X squared times x is x cubed. X squared times 2 is 2x squared. Don't forget to subtract. You're going to get negative 2x squared by doing that. Bring down the placeholder of 0x. X times negative 2x is going to give us negative 2x squared. Negative 2x times 2 is negative 4x. Don't forget to subtract. Leaving us with, I'm gonna make a mistake here. I want you to try to pick something out here. So it's going to be positive, negative 4x minus 1. And then, let's see, x times negative 4 is going to be negative 4x. Negative 4 times 2 is negative 8. So hopefully you saw that a mistake was made there. We're going to come back and check that out here in a minute. Right now, though, we have negative 1 minus a negative 8 is plus 8. Negative 1 plus 8 is 7. Okay? So let's pause on that. We'll come back to that in here in a second. Let's go ahead and put in negative 2 up here. So f of negative 2. So notice, we divided by x plus 2, but we're substituting in negative 2 into the function. Let's see what we get. So negative 2 cubed minus 1. Negative 2 times negative 2 times negative 2 is going to be negative 8 minus 1 is negative 9. So the remainder that we got here doesn't match that negative 9 there, and it's because of that mistake that we made. So let's go back and fix that mistake, and let's see if indeed when we fix that mistake that this remainder matches what we get over there. Okay, so let's take a look. So our mistake was right here. Hopefully you saw that. Minus a negative should be a plus 4. So if we fix that, I'll do this in blue, fix that to be a plus 4. That means when we come back here, x times positive 4, so we're going to fix this up here, should give us a positive 4x. And then 4 times 2 is positive 8. Okay, so we have negative 1 minus 8 should be negative 9. And indeed, they are equal now, right? And so hopefully we're seeing this pattern coming out of this. That whenever we substitute in this case negative 2, and whenever we substitute in the 0 of the divisor, so we didn't put 2 in to f, we put negative 2 into f. So we're substituting in the 0 of the divisor into the dividend, and when we do that, we get the remainder. This is what we call the remainder theorem. So if, for instance, they said divide this cubic by this x plus 2, this divisor here, and just give me the remainder. You don't need to give me anything else, just give me the remainder. We could have just done this really quickly and found out that the remainder was negative 9. So that's what's really interesting about this remainder theorem. So let me give you one to try. So try this one real quick. Go ahead and do the division and then substitute in and see if, in fact, this continues to work. Okay, so if we do the division here, I'm actually going to do the division x plus 1 into x squared plus x minus 16. Okay, so when we do this, let's see, x times x is x squared, x times 1 is x. Don't forget to subtract. When you do that, you get 0, and bring down the minus 16. And we're done, right? Because now all of a sudden, the degree of what's left is less than the degree of the divisor. So our answer here is x minus 16 over x plus 1. So let's see if when we substitute in negative 1 for the x values, if we get negative 16. So negative 1 squared plus negative 1, just go ahead and put those in parentheses just to be careful here. Negative 1 squared is positive 1, so that's negative 1 times itself. Minus 1 minus 16, the two 1's reduced to 0, leaving us with negative 16. So in fact, the remainder here equaled what we got over there. Okay? So this remainder theorem, yes, hopefully we're able to discover it by looking at these various patterns, but I also want you to understand why this works. Why does the remainder equal inputting the 0 of the divisor? Right, we put in the 0 of this, right? What makes this 0? Negative 1 plus 1 is 0, right? So negative 1 makes this 0. So that's what we put in to the dividend to get that out. So why does this work? Let's go ahead and investigate that a little bit. So let's take it in general. Let's say we have a general function f of x. We don't know what that is. It could be a cubic, quartic, quintic, whatever. And we're dividing it by x minus a. X minus a. And when we divide that, we get our answer here, which is the quotient plus whatever the remainder is divided by the divisor. So let's say we did the long division here, and this was our answer when we did the long division. Okay, so what I'm going to do here, I'm going to take this equivalency, and I'm going to show you why this whole remainder theorem works. So if we multiply everything by x minus a, so if we multiply this fraction by x minus a, we just get f of x. If we multiply g of x by x minus a, well, we just get the two multiplied. So g of x times x minus a. If we multiply this fraction by x minus a, we just are left with r, which is the remainder. Okay? So, we know that if we substitute in the 0 of the divisor, right? 0 of x minus a is a. So we know that if we substitute that into f of x, we should get the remainder, right? That's what we're testing here. So let's show why this works. So let's substitute substitute a into f of x, and we know f of x is equivalent to this, right? So let's substitute a in to f of x. So if we substitute a in on this side, we also need to put a in on the right side. So if we put a in for all the x values over here, we get g of a times a minus a plus r. Well, let's see here. F of a equals g of a times, well, what's a minus a? Should be 0, right? So 0 times g of a is still 0, leaving us with just r on the right side. So that shows us that f of a equals r. So when I put the 0 of the divisor into the dividend, it's equivalent to the remainder. So that shows why that is the case. And it also makes sense because if the remainder is 0, we know, let's say, for example, the 0 of the divisor is 2. If the remainder is 0, that means it's a factor, right? Which means that 2 should be a 0 of the function. As we talked about last video, 2 should be a 0 of the function, or 2 comma 0 should be an x-intercept. And so it makes sense, given the factor theorem that we talked about last lesson, it makes sense that this would be the case. But it actually works when it's not a factor as well. And so let's look at a couple applications. So what is the remainder when dividing this 7th degree polynomial by x minus 1. This would take forever to do long division, right? All we want to know is the remainder though. Well, we can input the 0 of the divisor into the dividend and we can figure it out. And it's a special case here because we're actually inputting 1, right? Because 1 is the 0 of the divisor. We're inputting 1 into the dividend. And if you remember from last video, we talked about inputting 1 into a polynomial, something special, right? If we input 1 into a polynomial, all we're doing is adding up the coefficients. So let's put in 1 into this. So 1 to the 7th is just 1, right? So we're adding up the coefficients. 1 plus 6 is 7, minus 2 is 5, plus 7 is 12, minus 4 is 8. So this would be the remainder of 8. All right. You might see, comment on T and ready, a question like this. It says, if the remainder when dividing f of x by x minus 3 is 7, so we know the remainder, it says which must be true. We don't even know the function involved here, f of x. We don't know the dividend. But we know something must be true. Okay, so let's tie this all back together now. If we were to substitute, is it 3 or negative 3? Remember, it's the 0 of the divisor, so it's not negative 3, so whatever makes it 0, plugging in 3 here would make it 0. So the 0 of the divisor is actually 3 in this case. So if we substitute 3 into the function, we should get the remainder, right? So f of 3 should equal 7. Again, f of 3 should equal 7. So f of 3 equals 7. So our answer here is C. Hopefully that makes sense there. All right? So this is an interesting property about polynomials and dividing them. Hopefully you were able to understand the remainder theorem and why it works, and then also how to apply it in various situations. So that's it for this video, and hopefully you'll join us next time.